So, do you have a heat pump or a furnace? And which one should you have? Good question, let's find out. So, let's start out. What is a furnace? Well, a furnace essentially takes a fuel, usually natural gas or propane, burns it in a heat exchanger, and passes air over the heat exchanger to heat the air. It's pretty simple, really. Now, how does it work in more detail? Well, first of all, the inducer turns on. This will draft air through the heat exchanger, which is really just a series of metal pipes, and out of the house. Second of all, the system will check to make sure the inducer is running and uses the pressure switch to do so. Once that's verified, the igniter turns on. Most modern furnaces use what is called a hot surface igniter, which, as the name suggests, will start glowing and getting really hot. You might, however, have a spark igniter like that you'd find on a gas grill, but that is by far so much less common. Next, the gas valve will open. This will start the flow of gas, and the igniter will also ignite the fuel. As long as the gas valve is open, the furnace will continue to operate. And the only way it will do so is by passing a few safety checks, including the flame sensor. This will detect a flame by generating a small voltage that goes back to the furnace control board. As long as there is sufficient voltage generated, the gas valve will stay open. If the flame sensor doesn't detect any flame, however, or the sensor is so dirty that it cannot generate any voltage, it'll shut off the gas valve. Next are the limit and rollout switches. These make sure the flame is only in the heat exchanger and not in the furnace cabinet, so that way you don't set your house on fire. Finally, once all those have been passed, the blower will turn on, then distribute warm air throughout the home. So, we talked about a furnace. What is a heat pump? This one's a little bit more complicated. In the most basic sense, a heat pump is an air conditioner run in reverse. An air conditioner is designed to absorb heat from inside a space using the indoor coil, called the evaporator, and move it outside to get rid of it using an outdoor coil, called the condenser. A heat pump uses the same cycle, but it's able to run in reverse. So instead, the outdoor coil will try to absorb heat from the outside and get rid of it using the indoor coil. The key to all of this is a component called the reversing valve. The reversing valve contains a sliding valve that can be opened and closed using a solenoid. Depending on if the power is applied to this valve or not, it'll dictate if the unit is in heating or cooling mode. Now, what are the pros and cons of everything? First of all, the pros of a furnace. First, furnaces use very little power. In a furnace, the only devices using any power are the blower motor, furnace board, and thermostat, unless you have any sort of indoor air quality devices connected. Second, furnaces have the potential to be very cheap to operate. These will very much depend on the fuel that you're using and how much that fuel costs. But in areas with cheaper natural gas and propane, like Texas for example, furnaces are a great option for heating. However, the main draw of furnaces is that they require a separate fuel source. This isn't an issue for many homes, as most of them have natural gas plumbed into it. But if you don't, you're dependent on getting fuel from elsewhere, like propane. Now, what about a heat pump? Well, first of all, it is the most efficient way to heat a home on electricity alone. Let's take a look at another form of electric heat real quick: resistive heat. This is something like a space heater, but also pertains to an electric heat kit, which is designed to provide central heat. There's a concept known as the coefficient of performance, or COP. In simple terms, this is how much energy you get over how much energy you put in. Resistive heat has a COP of 1 to 1, or really close to it. Heat pumps have a COP usually ranging from 3 to 1 to 4 to 1. So essentially, heat pumps are 3 to 4 times more efficient than resistive heat. Well, until you get down to a certain temperature. Since heat pumps move heat and do not create it, there's a certain point where you cannot transfer heat inside anymore. This is what's referred to as the balance point. While this will vary from system to system, is dependent on a number of different factors, generally this temperature is going to be anywhere between 30 to 35 degrees Fahrenheit. At this balance point, the heat pump cannot transfer heat anymore, and the outdoor unit begins to freeze up. This will put the system into defrost mode until the coil thaws out. So, how do you generally provide heat with the heat pump when it's below balance point? Well, by using an auxiliary heat source. Generally, this is by using resistive electric heat as mentioned above. This means that heat pumps, while incredibly efficient for heating in mild conditions, are nearly useless in sub-freezing conditions. And while there's some more efficient heat pumps out there, like hyperheat systems, most of them won't be able to heat below 30 degrees. Now there is another type of system called dual fuel systems, where a heat pump and furnace are combined.